Graphing a linear inequality is just like graphing a line. You want to get this into slope-intercept form, y equals mx plus b, so solve for y. But the thing that you'll notice is we don't have an equal sign. This isn't graph a linear equation with an equal sign, it's graph a linear inequality. So this less than sign right there tells us we're going to do a couple extra things with our graph. But first, let's get it ready to graph. Let's go ahead and get y by itself. So anytime you're solving for y, get the x to the other side first. So we have 3y is less than negative x plus 9. Those are not like terms, so we have to leave them separate. Let's go ahead and divide everything by 3. So we have y is less than. Now this negative x over 3, it's just like there's a negative 1 in front of the x. So I can say negative 1/3. Just put the x off to the side so it looks a little bit more normal to us. And then plus 9 divided by 3 is 3. So this is ready to graph. But let's talk about this inequality first. So if you have a less than, now this is in your notes, but just a reminder, if you have a less than or greater than, this is going to be a dotted line. If you have a less than or equal to, or a greater than or equal to, the ones that have that extra line, the or equal to line, that's going to be your solid line. So I could put arrows there. So if you look at what we have a less than. Should it be solid or dotted? Well, we said right here, if you have a less than, you're going to have a dotted line. So I'll make a note over here. Our line is dotted. Now the other thing we have to figure out, these linear inequalities have shading. You know, when we had open and closed circles on a number line and you shade to the right or to the left, similar idea, now you've got two dimensions, so you're in a coordinate plane, you're going to shade either above your line or below your line. So a less than or equal to, anything that is less than will shade below the line. If this is a greater than or equal to, anything that's greater than shades above your line. So which one do we have? We've got that less than, so less than shade below. So we will shade below the line. So now we have all the information we need to graph this line. We will start by just plotting our points. Well, let's identify. It's in slope-intercept form, so our slope is the number with the x, negative 1/3, and our y-intercept is the number on the end. As an ordered pair, throw that 0 in there, 0, 3. Alright, we start with our ordered pair, so we can plot our points first. This is just like how we normally do. Negative 1/3, down 1 to the right 3. We should be forming a downhill line. Backtrack the other way. Now, before you draw your line in, let's look at what did we say. Should we draw in a solid or a dotted line? We said dotted. Dotted, same thing as dashed. I think we tend to draw this a little bit more dashed. So you just draw in your line dashed, like that. Now the shading, are we going to shade above or below the line? We said shade below. Now, depending on the steeper your line is, the trickier it gets to figure out what's above and what's below. So just a fail-safe way to do this, if you have to shade below, go to your y-intercept, this point you plotted, draw a line below it, or an arrow below it. That's the side that we're going to shade. That'll work every single time. Just go to your y-intercept, draw an arrow above or below, and then depending on your inequality, and then that's what you shade. So then you shade everything below. So all of this gets shaded in. It's kind of fun when you get to have a highlighter, I have to admit. Oh, I'm off my graph. Oh well. So there you go. So what does all this mean? Everything that we shaded, those are solutions to this inequality. You could pick any point, any of these ordered pairs. We could pick this one, or this one, this one, this one over there. Any ordered pair in the shaded region, if you plugged in the x and y coordinates to your inequality, you would end up with a true statement. Now the reason why our line was dotted is because it does not include points on the line. If you were to pick, let's say this point right here, that's on your dotted line, plug it in, it would not give you a true solution or a true statement. So you're shading all of the possible solutions, but the dotted line just tells us that we are excluding the points on the line. So what's the solution to the linear inequality? Everything we just shaded.